Welcome to GKIT Solutions Private Limited.
SQL Server Integration Services, Classes and Real-Time Interview Questions and Answers. Part 42. What is the difference between synchronous and asynchronous transformations in SSIS?
In this part of training, we are going to discuss about what is the difference between synchronous and asynchronous transformations in SSIS. In SSIS, that is SQL Server Integration Services, transformations are categorized as synchronous and asynchronous based on how they process and pass data through the data flow pipeline. Synchronous transformations are processes each incoming row and passes it to the output immediately. It doesn't block the data flow and uses the same memory buffer as its input. For example, derived column, data conversion, conditional split, multicast, row count, etc. are the examples for synchronous transformations. Coming to asynchronous transformations, an asynchronous transformation blocks the data flow until it processes all incoming rows. It creates a new buffer and may increase memory usage. For example, sort, aggregate, merge join, union all, pivot, unpivot, etc. Coming to the differences, synchronous transformation and asynchronous transformation. First, the synchronous transformation uses the same buffer as input, and asynchronous creates a new buffer. And coming to synchronous, it is fast and no blocking, and whereas asynchronous, it is slower and data blocking. Coming to the synchronous, output row count is same as input, whereas coming to asynchronous transfer, output row count may differ. And last point is for synchronous transformations, lower memory consumption, whereas asynchronous transformations consume high memory. Let us see these things practically in SSIS. I'm in SSIS. I'm trying to create a new package here. Test what are the differences between synchronous and asynchronous transformations. I'm just trying to renaming it. Asynchronous transformations. Okay, all these transformations will be in data flow task. In data flow task, we'll be having different components like sources, destinations in between the transformations. For that, I'm taking a data flow task. Inside it, first we'll try to look at the synchronous transformations. For example, I'll take any source. For example, I'll take a flat file source here. I've taken flat file source. I'm just trying to configure just to show you all the things which have happened here. I'm taking this one, a sample file. And if you preview the data, this is the data available. And we'll check the synchronous transformations. What synchronous transformations are going to do? They'll just use the input memory which is available, and they'll not process all the data and get to the next component. They'll process row by row. For example, if you take a derived column, if you want to derive any new column, for example, on this, full name, here what it is going to do is first name, plus last. Let us say this is how we are just like concatenating the things here. Now what it is going to do is it will just create another column here, and if it passes from input row to the next output row, every time it will fetch a single record and it will join first name and last name, first name and last name. For like that, from the source, every row will come to derived column. That column is going to be processed and is given to the next transformation or next component. In such a way, row by row process is going to happen in asynchronous transformation. In the same way, if you take the data conversion also, for example, if you take any column, if you want to make the conversion. For example, ID, I want to, this is a string now. I want to make it like a 4-byte signed integer, something like that. See, I'm just trying to change it to an integer value. This is how what happens here also. From this before a component, it will just take a first row and it will try to change the data type for that. In that way, row by row process is going to happen. And finally, if you take any like OLEDB destination or any destination, it will just load the data. Here from all the components, what we have defined from first file, if you have 100 rows, row by row, you'll get into the last destination. For example, I'm just connecting, just making it. I am not like here from the flat file. For example, there are 100 rows. First row will get into derived column. Here, new column is going to be created, and along that new column, the data is get into the data conversion, the second row, and finally data is going to be inserted. In that way, 100 records are going to be inserted by following these transformations without blocking. The memory also, input memory, it is going to use. This is in such a way we are having different transformation as we discussed in the previous slide for asynchronous transformations, like conditional split, multicast. These are all synchronous transformations. Coming to asynchronous transformations, to test them, I'm taking another data flow task. Here I'm trying to make a source connection. For example, I'm taking the same source. And here the blocking transformations are like, for example, take sort. Okay, sort is like a blocking transformation or asynchronous transformation. What it's going to do is it will create a new memory. For example, if you have 100 rows from the flat file, what it is going to do is it is going to sort based on all the columns which are there, and it will create separate memory. It will get all the data in that separate memory. It is going to sort all the data, and for the next phase it is going to provide you. For example, if you take any I'm taking another asynchronous transformation like aggregate. I'm taking aggregate here also. Aggregate also, I'm just trying to perform a kind of an aggregate here, like it is a integer column, just count. I'm just trying to make a count, group by distinct count. Okay, some aggregation operation I have taken. I'll explain you all the things here, what is going to happen. And OLEDB destination, I'm just trying to take here. See here what happened when you try to create a new thing. Here from the aggregate you'll be having a single column. Okay, that is what we have explained. See, first phase there will be 100 records. If it comes to the sort, it will not get a one by one row processing here. It will get all the data here. Here it will take some memory. It will sort all the data, and this data is going to be given to the aggregate. Here, based on that particular column, it will aggregate all the data for that 100 records, and after that it's going to get into the output. That means here the source columns are going to be different in the target column. For example, you create any aggregate here, it will be creating only one column. If you sort based on something, the columns from the like source to destination are going to be changed, whereas in synchronous transformations there won't be any change in the columns from the source to destination based on the target table. In such a way, the asynchronous transformations are going to process the data wholly, and it will take separate memory to consume, and it will block the data for some time to perform some kind of sorting and aggregation kind of things. In such a way, we are calling these transformations are like asynchronous transformation. Why? Because these are not syncing from first to next like component. In such a way, the synchronous and asynchronous transformations are differ in their functionality. Synchronous transformations are like row by row process, whereas asynchronous transformations are whole data transformations. For example, from the first component, the whole data is going to get into the next component. It will process all the data by taking separate memory. Instead, synchronous transformation process the data in the in-memory itself. That is why, coming to the performance wise, synchronous transformations are faster compared to the asynchronous transformation because of the process which is happening in the separate memory. I think you got some idea about the synchronous and asynchronous transformations. Thank you.
Stay connected with GK IT Solutions on all your favorite platforms. Follow us on YouTube, LinkedIn, Instagram, and Facebook. Don't forget to like, share, and subscribe to our YouTube channel and press the bell icon to stay updated with all our latest content. Join the GK community and grow your IT career with us.